Welcome to the wonderful world of Harry Potter. Actually, I think it's the wizarding world of Harry Potter, but we're just going to roll with it. Today, we're going to be diving into our first part of our unit, Properties of Matter, and it is one of my favorite units because it deals with chemistry. So let's go. But before we get started, let's have a little discussion and use some qualitative evidence to figure out how does the sorting hat choose which house a wizard is placed into. How does the sorting hat choose which house a wizard is placed into? Let's look at some qualitative evidence by observing.
It's not real, the ceiling. It's just bewitched to look like the night sky. I read about it in Hogwarts, a history.
Will you wait along here, please? No. Before we begin, Professor Dumbledore would like to say a few words.
I have a few start-of-term notices I wish to announce. The first years, please note that the Dark Forest is strictly forbidden to all students. Also, our caretaker, Mr. Filch, has asked me to remind you that the third-floor corridor on the right-hand side is out of bounds to everyone who does not wish to die a most painful death. Thank you.
And when I call your name, you will come forth. I shall place the sorting hat on your head, and you will be sorted into your houses. Hermione Granger?
Oh no. Okay, relax. Mental, that one, I'm telling you.
Right then. Right. Okay. Gryffindor!
Draco Malfoy.
Slytherin!
That's not which job wizard who went bad, it wasn't in Slytherin.
Susan Bones.
Harry, what is it?
Where shall I go?
Nothing, you're fine.
I know. Hufflepuff!
Ronald Weasley.
Ha! Another Weasley. I know just what to do with you. Gryffindor!
Harry Potter.
Difficult, very difficult. Plenty of courage, I see. Not a bad mind either. There's talent, oh yes, and a thirst to prove yourself. But where to put you?
Not Slytherin. Not Slytherin.
Not Slytherin, eh? Are you sure? You could be great, you know. It's all here in your head. And Slytherin will help you on the way to greatness. There's no doubt about that. No? Well, if you're sure, better be Gryffindor!
All right, so using our qualitative evidence, how does the Sorting Hat choose which house a wizard goes into? Well, if we think about what he was saying about Harry, he started listing qualities or characteristics or properties of Harry Potter. That he has courage, that he has a great mind, a thirst to prove himself. Those are all characteristics of a person. And just like people have characteristics, things have characteristics, items around you have characteristics, but we call those properties. So I like to refer to the periodic table of elements as the original sorting hat because all of these elements are sorted by their properties, the things that make them unique. But before we even get too far into it, let's rewind and figure out what is an element. What is an element? Well, Dimitri, we're going to call him Dimitri because I can never pronounce his last name. Dimitri analyzed, which is a fancy word for examined, the properties of elements and sorted them in what is known as the periodic table of elements. So Dimitri not only sorted these elements based off of their properties, but he also was able to put a placeholder where an element was not quite yet discovered, but he knew once it was, that is where it would go. He was able to tell us what its atomic mass would be. He was able to tell us what type of properties it would have because of the surrounding elements that he did know. So he was not just an organizer, but he is like Science Hall of Fame. So what is an element? Well, an element is a pure substance. Let's say that together. An element is a pure substance that is made up of only one type of atom. How many types of atoms? One. And each element has its own properties that differ from other elements. So whereas people can kind of have the same characteristics, elements are completely different in their properties. There's no two elements that are exactly the same. We're all different. And elements can be identified by their atomic number and element symbols, which we're going to look at a little bit later. And elements cannot be broken down. So because they are a pure substance made up of one type of atom, they cannot be broken down anymore. So this is an atomic number. It is usually found at the top of an element square. Then we have an element symbol. Now your element symbol is made up of one or two letters. The first letter is going to be capitalized. If your element has a second letter, then that second letter is going to be lowercase. You're going to have an element name. So in this case, our element is aluminum. And lastly, you're going to have the atomic mass. So all of this is going to be included on the element square that is on the periodic table of elements. And elements can be found in all living things because they are an atom. They're made up of atoms. And atoms can be found in all living things. Without them, our world and everyday items would never exist. And elements, they can be modeled using shapes. For example, chlorine is represented as a square. So looking at our different ways to model chlorine, one square is one chlorine atom. Now you can have multiple chlorine atoms, and you can represent this by having your shapes overlapping, or they can be separate. So you can represent multiples of the same element by overlapping or having two shapes, but it must be the same shape. So since chlorine is represented with this square, then chlorine atoms, or the element chlorine, are going to be shown as squares only. So let's recap. Elements cannot be broken down, making them a pure substance. You can look up an element name by finding the element symbol on the periodic table. You can represent an element by using a specific shape, and multiples of that shape mean multiples of that element are present. And elements make up all living things. Now, because they make up all living things, I'm going to play one more video for you, and it's going to cover all of the elements that are on the periodic table right now and what they are currently used in. So that way you can see that elements do make up every single thing that you see around yourselves, okay?
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air, oxygen so you can breathe, and chlorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shell, electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel, points again, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine, film, krypton, helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and helium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, chromium, erbium, thulium, ytterbium, lutetium. Hafnium, tantalum, tungsten, then boron, rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead that is meant for your tummy, polonium, astatine would not be yummy, radar, and cesium will last a little time, radium, then actinize at 89. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shell, electrons are to the right. Actinium, thorium, titanium, uranium, neptunium, plutonium, uranium, curium, berkelium, californium, isonium, chromium, indolinium, nobelium, thorium, rutherfordium, strontium, borium, hesium, uranium, neptunium, mercurium, cobernicium, natrium, ferrovium, adamantium, livermorium, adamantium, adamantium, and then we're done.
Awesome. So you guys, that is our notes for the day. Please go ahead and you can store this in your YouTube playlist or download that PDF onto your device. I will see you guys later. This is DJ Enzyme breaking it down.